RISC-V is a free and open instruction set architecture created in 2010 by computer science professors David Peterson and Andrew Waterman at the University of California, Berkeley. Their goal was to develop a general-purpose ISA that could be used across various applications and drive innovations in the computer chip industry. Today, RISC-V has become one of the most popular ISAs worldwide, with applications in embedded systems, the Internet of Things, servers, high-performance computing, and artificial intelligence. Its success lies in its flexibility, openness, low cost, and customizability. In China, RISC-V has gained widespread attention and development. Many domestic technology companies have invested significant resources in research and funding to promote the RISC-V ecosystem. In hardware, several chip manufacturers have introduced processors and SoC chips based on the RISC-V architecture, such as Software, Allwinner, Star5, and C5, with different performance and power levels to adapt to various application scenarios. On the software front, the RISC-V ecosystem is continuously evolving, covering various tools like operating systems, compilers, toolchains, and libraries. RISC-V now supports multiple operating systems like Linux, FreeBSD, Zephyr, and FreeRTOS. The inclusion of RISC-V has brought more opportunities and challenges to openEuler, an enterprise-level operating system built on open-source technology, and attracted more developers and users to the openEuler community. In summary, RISC-V has a bright development prospect, with its openness, flexibility, and low cost, providing more options and possibilities for applications in various fields. It is expected to become a technology with commercial potential and play a more critical role in chip design, operating systems, and application programs.
Welcome to the openEuler Tech Day. I am very glad to be here today to share with you something about the openEuler and openEuler RISC-V. First of all, as a brief self-introduction, I am Zhang Xuzhou, one of the maintainers of openEuler RISC-V SIG. I have worked at Huawei as an OS expert for about 5 years. My work mainly focuses on operating system techniques, such as heterogeneous memory management and CPU ISA. As you may know, openEuler is an innovative platform that builds a unified and open source operating system which supports multiple processor architectures, such as x86, ARM, long arc, and RISC-V. It is driven by community collaboration and aims to provide a platform for promoting the prosperity of software and hardware ecosystem. openEuler is not only an OS platform, but also a vibrant and diverse community that welcomes everyone who is interested in contributing to the development of open source software. The openEuler community has established several special interest groups to focus on different aspects of the OS, such as security, kernel, virtualization, storage, and, of course, RISC-V. They are composed of community members who share common interests and goals. They work together to develop, maintain, and improve openEuler software packages and features. The community also organized various events and activities to promote communication and collaboration among members. One of the most important things are the RISC-V SIG, which is dedicated to porting openEuler to RISC-V architecture. As one of the startup members of RISC-V SIG, I want to share you my experience to show what you can do in openEuler community. The RISC-V SIG was established in June 2020. At first, we started to build the openEuler RISC-V from the scratch. As in the number of ported software increases, the openEuler RISC-V was capable of continuous integration. Then, with the assistance of fundamental infrastructure SIG, the first batch of openEuler RISC-V software packages was built using Open Build service in August 2020. Finally, in September 2020, the first version of openEuler RISC-V was officially released as the first RISC-V Linux distribution in China. The latest news is that the openEuler RISC-V has joined the RISC-V Foundation's landscape. This cannot be done without the efforts of hundreds of RISC-V SIG members. So, do you want to know more about openEuler RISC-V? My friend will bring you more interesting things. Just stay tuned. Thank you.
In PLCT Lab, we maintain and provide support for almost all the key system software for the RISC-V ecosystem, including the GNU and the LLVM toolchain and the core virtual machines like Camel, OpenJDK, V8, and SpiderMonkey. By working side by side, we are excited to see that openEuler now becomes one of the most powerful and widely used Linux distribution for RISC-V.
Yes, we successfully ported SpiderMonkey to RISC-V in PLCT Lab. The openEuler guys immediately started integration and testing on it. The new feature boosts the speed of JavaScript in Firefox browser up to 40 times. Especially the image rendering mode gains 2 to 3 times enhancement. The openEuler is quick and profitable.
The dashboard next to me is an Starfire Vision 5 with openEuler running on it. This on screen are the English homepage of openEuler project and Institute of Software, Chinese Academy of Science, in Firefox browser. In ISCS, we have several dedicated teams for porting software and operating system to RISC-V architecture, such as LibreOffice I'm switching to. I can eat glass, it doesn't hurt me. Thanks to these porting efforts, we have many applications on openEuler RISC-V now. We are thrilled in ISCS to contribute to openEuler's ever-growing, diverse ecosystem and make it greater. Thank you.
The Institute of Software, Chinese Academy of Sciences, is committed to supporting the development of the RISC-V and openEuler communities. As a premier member of RISC-V International, we actively participate in the development of international standards for RISC-V and contribute to the upstream of the important open source software. As a vice chair member of the openEuler committee, we take an active part in the construction of the openEuler community and jointly promote software adaptation, version building, and supply chain security of openEuler. The ISCAS has become a recognized development and technical training partner of RISC-V International and has received multiple international awards. In the future, we will continue to gather core technologies in the key fields to provide high-quality open-source software and technical support to users worldwide, promoting the prosperity of the RISC-V ecosystem. Thank you.
Hi, my name is Xin Liu, and I'm currently an OS development and porting engineer at openEuler RISC-V. The fundamentals of a Linux distribution are packages. Currently, openEuler has more than 9,000 packages, and maintaining that amount of source code is not easy, let alone creating a separate repository to maintain and synchronize it. So in this case, openEuler RISC-V shares the same codebase with both x86 and ARM architectures. This ensures that we are always aligned with other architectures at all times, allowing us to quickly see which packages are not supported on the RISC-V architecture, while compiling so that we can fix them and submit the changes. At this time, openEuler RISC-V had already supported more than 4,000 mainline packages and 1,000 extra packages. Our goal is to further expand support for all packages. When porting, different errors require different solutions. For cross-architecture friendly packages, the simplest error is the lack of definition of the RISC-V architecture in the spec file, such as biometric authentication. The configuration file error is next. For example, Echo, which was developed by cloud-native SIG for Kubernetes clusters, does not add definition of the RISC-V architecture in Makefile. Bisheng JDK8 is also a fundamental component of openEuler, and its source code files for identifying the platform, which are config.gs and config.sub, are also not defined in the RISC-V architecture. Similarly, there is a need to add predefined compiler macros for the RISC-V architecture in the source code, for instance, in the STB package. Another type of error requires adding instruction set support. An example is the open-source relational database management system OpenGauss. The instruction set in the source code of the software is only defined for x86 and ARM. The port is still in progress, and we are expecting to deliver it in the next innovation release. For large-scale software, such as Firefox, porting requires a number of different factors, from base package versions to compiler toolchain support to graphics support. When we started porting in April last year, we upgraded both ICU and Half-bars ahead of time to lay the foundation for testing Firefox without system ICU. As a result, Firefox was quickly ported to openEuler, and a foundation was laid for further optimization. In addition to general porting, the bottleneck of large-scale software on the RISC-V platform usually occurs in JIT. Currently, openEuler RISC-V has a number of packages with JIT complication support. To tell you more about this, here's Jingwei Wang.
Thank you, Liu Xin. I'm Wang Jingwei, and I'm currently working on the porting and optimization of the openEuler RISC-V platform. With the help of PRCT Lab, openEuler RISC-V SIG has successfully ported and optimized major packages such as Firefox, MSA, Rajit, and so on for the RISC-V architecture. These large-scale porting efforts have made openEuler RISC-V one of the most advanced RISC-V distributions. Last year, the PLCT lab engineers completed the SpiderMonkey GIT port for RISC-V. I adapted their work for Firebox 108 on the openEuler RISC-V platform, and it runs successfully. Testing shows that the GIT-enabled JavaScript interpreter had a performance improvement of up to 40%. In addition, we adapted the RISC-V LLVM GIT optimization for MESA done by PLCT Lab and enabled RustCL support. I am setting that to a machine that is running Firebox with MESA based on GIT optimization, and it looks good. This machine is unmatched, and the environment is openEuler. Furthermore, in the beginning of this year, PLCT Lab's port of Realize has run on the RISC-V 64 platform. This means that openEuler RISC-V can now easily support more high-quality open-source software, such as openRISC-V. We have set up a hardware demo based on the official example of openRISC-V. The development of Realize is still ongoing, and openEuler RISC-V will continue to be updated. In our future work, our team will continue to promote GIT optimization for the openEuler RISC-V system, such as OpenJDK 1.8, Mosaic.js 102, and PCIe 1. These efforts are expected to significantly improve the performance of RISC-V elements in different aspects. GIT optimization and porting are currently the key and difficult points in the RISC-V platform. openEuler RISC-V SIG and RSCS work closely together, keeping up with the latest developments in relevant fields and striving to achieve a smoother user experience for commonly used desktop software. My work and that of Liu Xin are based on individual software packages. Zhou Jiachen integrates our work and brings an out-of-the-box distributions to everyone. Now, let's hear from Jiachen.
I'm Zhou Jiacheng, a junior developer and release engineer at openEuler RISC-V. In terms of building a full operating system from source code, reliable and reproducible are the most prominent keywords in my mind. At the openEuler RISC-V, our open building service instance is the center of all development and testing activities. With over 200 kernel worker cores at peak, it empowers us developers to create and port any software packages for RISC-V architecture at their own pace, without worrying about computing power. GitLab CI is our selected way to make system images and software repositories for various plugins, such as kernel virtual machines and RISC-V dev boards from different vendors. Continuous integration and automatic deployment contribute much to our effort to make our distribution have the same behavior on ARM targets as possible, which makes rooting out bugs and issues more easy. After the building system finishes baking a batch of packages, the freshly cooked products will be sent to an internal repository on the same machine where our CI workers live. When the time arrives, a worker will start their job to create new system images from these packages for software developers, testers, or final users if the corresponding release is considered mature enough and okay to go. And the images and snapshot repositories will be sent back to the same place for further manipulation and delivery. To make system releases more predictable to everyone, several ORSP community guidelines has been proposed, and we are expected to release every build in a given plan or schedule. For delivery of our built products, we rely on the open source mirror of the Institute of Software, Chinese Academy of Science, to be the primary distributor. And some of the more mature preview builds can be found on the official openEuler repository and its downstream mirrors as well. Many thanks to these mirror teams from universities, organizations, and companies. and everyone involved for their support of our project and open source software as a whole. Thank you.
Hello, I'm openEuler RISC-V QA team leader. My name is Yunxiang Guo. Today, we talk about openEuler RISC-V quality assurance. The quality assurance of openEuler RISC-V aims to test the software components that make up each openEuler RISC-V release. Our goal is to improve openEuler RISC-V community quality and testing capabilities. This is our main activities, include 5 steps. First, we build test capabilities and involve the community developers in use and contribution. Second, draft, release, and maintain release criteria. Third, develop and maintain test tools to promote code development and execution efficiency. Fourth, make test plan and choose cases to execute the plan. 5. Organize the test open days which focus on testing a specific feature or component. We take the test in package test and version test. Package released by the openEuler RISC-V community include upstream openEuler community software and RISC-V community original software. The quality of our software package is assured through the following methods: the quality gate check, developing check, and community cloud testing. In version test, for the release plan of the openEuler Community Edition, the RISC-V QA team is responsible for the quality assurance of the planned version. The openEuler RISC-V Community Edition build includes the daily build, beta build, and release build. When a developer submits the modification to a software package in a PR, the quality gate check of the continuous integration project is triggered. After the quality gate check is passed, the compilation and building of the software package is started. Currently, the quality gate check planned by the openEuler RISC-V community include check items for lessons, basic information, interface changes, and sensitive information. The maintainers of each project need to review the quality gate check results. In the developer testing, we focus on the specific file which build the binary package. This ensures that modification to the source code does not impact the basic interface or functions of the software package. The quality assurance of the aspect depends on the developer's contribution of the test code. When submitting a patch, you can supplement or modify the test cases in the source code to enrich the basic verification capabilities for interfaces and functions. As a patch submitter, you can also create a test issue in the corresponding project and describe the function of the patch so that other developers can understand the change and contribute test cases. The openEuler community compiles with the upstream first principle. You are advised to contribute patches and test cases to upstream community because changes in the upstream community will be synchronized to the openEuler. Directly contribution, patches, and test cases to the openEuler community is also appreciated. As an open and innovative Linux community, openEuler RISC-V welcome all developers in the industry and participate to the various community activities. Community cloud testing requires more developers to participate in the quality assurance activity. You are welcome to perform the tests, verification, and quality assurance on software packages that are imported or modified due to the new features and upgraded packages that are heavily modified. We take the version test in daily build. The CI project pulls all the corresponding package from the project repositories, compiles the package, and then integrate and build an ISO image of the daily build. After the build is successful, a small test of the daily build is automatically triggered. These test items include installation and deployment, software package installation and uninstallation, component tests like kernel, virtualization, container, and compiler, system integration, system service like logging, firewall, partitioning, service status, and etc. We also take the beta build. Based on the daily build, beta build integrates new requirements and features planned in the official release and is provided for the community user as a preview version. This build meets the basic requirements of the community user and the build quality is stable. Before a beta build is released, the QA team performs and organizes more comprehensive tests, including the following items, such as smoke testing, function verification for the new requirements or features, performance testing, upgrades, community cloud testing. Finally, we take the release build testing. Release builds in the community release plan include LTS versions released every 2 years, and the innovation version released every 6 months. A release build is an official version released by the community and has higher quality requirements. This requirement build test item includes bait build testing, stress testing, security testing, capability testing, and in the end, document testing. The future of the RISC-V computing is at the turning point with significant growth ahead. We are inviting you to join RISC-V's QA activities. You are welcome.
Hello everyone, I'm Xiaoqian Lu from Test Development Team in openEuler RISC-V SIG. And today I'd like to share some progress of the openQA used in our testing. There has 3 parts in my sharing. First, I will give you a brief overview of openQA in case you are not familiar with this tool. The openQA is an automatic test tool which could help us test on both serial console or screen output. It provides a web application and workers. The web application provides a browser to show the configurations and details of the test. The test engine on Worker will create a virtual machine to execute the test process. The deployment is very flexible. They can run on same machine or on a distributed way. You can get more information from their official website if needed. Now let me introduce our achievement. We have successfully used the openQA in the test of openEuler RISC-V with the backend QML. And we are working on automating test case to improve our test efficiency. This is a demo. In this case, openQA creates a openEuler RISC-V QML to test the bookmark function on Firefox. Like this, we can test other desktop applications or trigger test by command line, such as Magen or any other test suites. openQA is designed to test on virtual machine. We will adapt the code to test on hardware device to do the compatibility test. We will improve our automatic test coverage with our team and community partners. Thank you for your listening.
Hello everyone, I'm Long Chan Cheng from QA team in openEuler RISC-V SIG. Today, I want to share with you the testing framework Mugen we use. Mugen is a testing framework opened by the openEuler community. Mugen includes the following 4 aspects. The first is rich openEuler test code. The second is a set of specification for writing test code. The third is a function library to assist in writing tests. And the fourth is an execution that can simplify the test execution process program. Since Mugen was initially only available for openEuler, we ported Mugen to openEuler RISC-V last August. After our porting work, Mugen RISC-V now has 329 test suites with a total of 1,426 test cases. In addition to the increase in the number of test cases, we also wrote auxiliary scripts to help us further analyze the test results. Compared with the upstream Mugen, many new functions have been added, such as sorting the logs of passing and failing use cases separately, automatically restore the test environment, and isolate the test environment of each test suite. Next, we will continue to optimize the auxiliary scripts and more test cases, and consider porting Mugen to other operating systems. Thanks for watching. If you are interested in our work, welcome to join.
Hi, Operations Manager intern for the openEuler RISC-V. Currently, I'm a graduate student studying applied statistics at Montreal University. I assist with the operations of the RISC-V SIG, and I'm dedicated to promoting the development of the openEuler RISC-V. I think open source is really cool because it attracts people who want to contribute to open source technology. We welcome more friends to join us in the development of openEuler for RISC-V architecture. The openEuler RISC-V SIG was co-founded by openEuler and ISCAS. Its mission is to build RISC-V architecture operating system for openEuler, provide customized development of RISC-V software and hardware environments, and support related software packages, promoting the development of China's RISC-V software ecosystem. Now, openEuler RISC-V SIG invites interested partners and hopes to join you in the RISC-V software ecological construction. There are 4 choices. First of all, we invite interested partners to join the RISC-V email list created by openEuler. You can access the subscription page by clicking on the community button in the menu bar of the openEuler community website. Then, searching for RISC-V SIG to subscribe and exchange ideas. We have also created a RISC-V category in the openEuler community forum. You can access the form by clicking on the interaction button in the menu bar of the openEuler community website. Then, selecting other technical issues and RISC-V. Next, you can access the openEuler RISC-V SIG project homepage on Getd. The various repositories under the openEuler RISC-V organization are maintained by the RISC-V SIG. You can visit this page to join the contribute pod.
Thank you, my friend. Porting is very exciting as it unveils countless possibilities and opportunities when our operating system works with a new device. Making all of that happen is not super complicated, however. There are several portions to consider when making an OS image for hardware. rootfs, kernel and drivers, then firmware and bootloader. Their relations are shown in this graph. It's like a layer cake to some degree. rootfs in the top layer, kernel and driver in the middle layer, and firmware and bootloader in the bottom layer. Let's start with the top layer, the rootfs. rootfs is the least concerning part of the porting procedure. To keep the consistency of different platforms and targets, we should not change many things in rootfs. Leave some new configuration there, in most cases okay. Remove or add something existing, probably is a no-go. Kernel. Mainline kernel from distribution or upstream is preferred to minimize the maintaining burden. Meanwhile, the mainline kernel is probably not satisfying enough for booting the machine without modification for most new devices. It's a typical case and not much to complain about, in my opinion. Then we can turn to our Windows kernel source tree for help. It's the very case of Windows 5 that our kernel tree is from Starfire, the manufacturer. Dealing with the Windows kernel tree means there can be some Windows-specific configs and document changes and other things only people in the Windows own communities and chatting groups know how to do. It can be somewhat social intensive, but don't hesitate to ask until you get the necessary information. It's typical that no available open source drivers or code can make the part work, like the Imagination GPU on Mission 5.2. Forget that for now and do as much as you can. Give some time for our lovely community to figure that out. Next, let's talk about firmware bootloaders. You don't have much choice in SPI interface implementation. The de facto standard openSPI or the newly emerged RISC-SPI as an alternative. For bootloaders, we have U-boot and EDK2. The former is common in the embedded world, the latter is likely seen on full-fledged workstations and servers. For U-boot, you may need to take care of the environment variables where the booting parameters and methods are defined. Add variables through uenv.text if required. Like the kernel case, we often need to turn to the vendor forks facing a more unclear upstream schedule, and so on. On version 5.2, both the U-boot and openSPI we utilize are from Star5, as the mainline effort is still ongoing at the moment. Finally, collaborating with the community can boost our porting efforts as well. For example, when we need extra changes or patches during the bring-up, other than vendors can help. On version 5.2, while open sourcing our ongoing work, we also closely track the community progress and adopt several patches from the Star64 repository, authored by Asmon Zhen. Many thanks to her and everyone involved in making the community a better place. That's all for me. Thank you for listening, and let's welcome my colleague for the next section.
Hi, I'm Eustace, currently a member of openEuler RISC-V Special Interest Group. The topic is a reference distro on RISC-V architecture. Let's dig in. RISC-V is an open source instruction set, follows reduced instruction set computer principles. Free, open source, and high freedom make it more and more concerned by more and more people. It also attracts many people to participate in the construction of its ecosystem. At present, RISC-V hardware is beginning to take shape, and the corresponding software is also being promoted. Adapting openEuler to RISC-V architecture is one of such projects. Why openEuler base? There are some reasons. First is the early exploration on RISC-V architecture. For example, it can run on UCAS NOT shell processor at the year 2020. Second is that core components are well supported. Bisheng JDK was the first one to finish RISC-V Java Development Kit implementation. Third, the scale of packages that meets our need after a period of development. Commonly used software packages have been included. We have not short development history of this distro. In 2021, based on openEuler RISC-V early development build, I rebuilt a small number of packages from 2109 repository, test on Sci-Fi Unleashed virtual board. In early 2022, based on previous build 2109 version, new version pulled from 2203 repository. The package scale has been further expanded. In middle 2022, the package scope is planned to be expanded to align with that what openEuler officially supported. There is still some problem with current development method. openEuler RISC-V is undergoing rapid iteration. There are differences in maintenance policy, something just like commercial support. The community version is a basic framework that requires further modification to become a product. Some changes are not easy to quickly return upstream and see the results. We have diversified development. The aim is to provide end users a good experience. So, developers do more, users suffer less. Now, introducing Euler theorem. Probably the first openEuler distribution to include RISC-V as first-level support, so-called Tier 1 support. We mainly support RISC-V architecture. The same code base can also be used to build images for other architectures, provides a consistent experience. For desktop scenario, we have Kiran desktop environment inbox. It's familiar and easy to use. Include basic sets of applications for your common usage. For server scenario, as we all know, openEuler is mainly phased to servers. It has a large number of server software included. We provide container support, like Docker engine on RISC-V architecture. It provides a base environment for you to explore more on RISC-V and get lots of fun. We maintain some leading and popular applications, like Firefox, Chromium browser, Evolution Mail, LibreOffice Suite and Media Player. Real hardware must not be absent. We have images on Allwinner D1 series, Nerja boards, and Star5 Vision 5 series. This year, powerful RISC-V machines are approaching. That's the future. Welcome, download and test the product. We are glad to hear from you. You can visit our project home from the link above. You can also connect us from RISC-V Special Interest Group. Thank you for listening and have a good day.
Some people ask us, what is the future plan of openEuler RISC-V? Also, it is impossible to give a complete list. We do have 4 goals at present. First, openEuler RISC-V process to enter QA-SIG and release SIG, also influenced in 2309. In the past, due to the comprehensive impact of software adaptation progress, fast fix speed, and the best building efficiency of the building platform, the RISC-V architecture could not meet the time requirements for version release as a new architectural adaptation. Therefore, the RISC-V SIG released an openEuler RISC-V image separately as a preview version for users to experience only for learning and communication purpose. Currently, the distribution of the RISC-V is based on x86 _ 64 virtual machine, and there is still a shortage of resource. We expect that after SG2042 machine is connected to the RISC-V building platform, the building efficiency can be greatly improved, and the RISC-V can enter the openEuler mainline at the 2309 version node. Second, long-term maintenance version 2203. The RISC-V SIG will continue to maintain version 2203 until 2025, aiming to provide users with a relatively stable version. Third, 2403 Realize the LLVM Parallel Universe project. In addition, the RISC-V SIG and the compiler SIG have launched the openEuler's LLVM Parallel Universe project. The efficiency and the community activity of the LLVM Surface GCC. The project attempts to build software packages by LLVM. The parallel universe will start building from March 2023 and plans to implement in March 2024. First, prediction of HPC entering top 500 in 2025. Some people say that 2023 is the year of RISC-V HPC. If the RISC-V architecture wants to become one of the three major instruction sets on par with x86 and ARM, it must establish its position in cloud computing and high-performance computing. Currently, with the mass production of the RISC-V, 64-core high-performance processors, SG2042, openEuler RISC-V has finally found a suitable hardware covering cloud computing and high-performance computing. We boldly predict and hope that HPC will enter the top 500 in 2025. Anyway, openEuler will become a trusted, preferred Linux distribution, whether it is x86, ARM, or RISC-V.